Graphs and symmetry. The objective for this video lecture, we want to test an equation for symmetry. Okay, let's take a look at what symmetry means and the different cases we're going to be looking at. Okay, so symmetry is simply one shape. In our case, it'll be a graph, so it'll be a line or a curve. Becomes exactly like another when you move it in some way. And we're going to be flipping it over a line of reflection or turning it around about a point. Okay, so these are our three situations that we're going to be dealing with. Okay, the first one, and again, I'm on the coordinate graph here. The first one is symmetry with respect to the x-axis. So here's the x-axis. You can think of it as a line of reflection, where if we were to fold this over the x-axis, these two pieces would match up. And forgive me if my drawing's not perfect, but I think it's pretty clear to see that, if we were to fold it about the x-axis, this would match to here, this would match to here, this would match to here, etc. Okay, so again, we're reflecting about the x-axis. And what it means from an algebraic standpoint, from a point standpoint, is that for every xy you have on the graph, okay, the point x opposite of y is also on the graph. So notice, for every x, you have two y's, a y and then opposite of y, okay, which is what this speaks to right down here. Let's take a look at symmetry with respect to the y-axis. So again, I'm on my xy plane. In this case, I've drawn a parabola, and you can see that if the y-axis is a line of symmetry, that I could fold it on the y-axis, and that this half over here would match onto this half. The left half would match to the right half. So it's reflecting about the y-axis. Notice in this case that every y has two x values, the x and the opposite of x. So no matter what y you choose, all these y, of course, except for down here, in this case, the minimum only has one x value, but whatever y you choose, you're going to have two x values. So for every point xy that's on the graph, so is the opposite of x and y, in order to be symmetrical about the y-axis. Okay, the last situation, I'm going to slide it up just a little bit. The last situation has to do with symmetry about or with respect to the origin. Okay, so I've drawn a curve here, and what you look for with symmetry about the origin is if you can hold, let's say you hold your pencil or you hold a pen right here about the origin and you spin it. If it matches itself in a spin that is less than 360 degrees or a less than 360 degree rotation, then it is symmetrical about the origin. So if I put a pin here and I rotate, well, this point will rotate to here after 180 degrees. This point will be down here. The origin, of course, doesn't move, okay, but it'll spin, and after 180 degrees, it'll be right where it is, okay? So you'll also notice that for every xy that's on the graph, the opposite of x and the opposite of y are on the graph, okay? So for every point xy, the opposite of the x and the opposite of y are also on the graph. And I have one more comment, so my sheet can be a little bit lower here. I think I can still cover it. Yes. Every point's matching point, okay, so this point's matching point is the same distance from the origin. So from here to here and from here to here is equivalent, the same distance, but it's in the opposite direction. So we went into the first quadrant, we go into the third quadrant. It's in the opposite direction. So there you have symmetry with respect, let me come down a touch, excuse me. There we have symmetry with respect to the x-axis. If you fold on the x-axis, the two sides match up. Symmetry with respect to the y-axis. If you fold along the y-axis, it matches up. And symmetry with respect to the origin. If you hold it up, if you pin the origin and you rotate it, and it matches up in a less than 360-degree rotation, it is symmetrical about the origin. Okay, algebraically, we're going to use these facts right here to assist us in testing this algebraically. Okay, so test for symmetry algebraically. So, symmetrical about the x-axis. Well, what do? You replace the y with the opposite of y, because you remember, every x has two y's. So if you can replace the y with the opposite of y in the equation, and the equation is unchanged, it's symmetric about the x-axis. Now you may have to do a touch of math to see it, okay? But your goal here is replace the y with the opposite of y in the equation, and then see if the equation can be written unchanged. Okay, as you might imagine, symmetry about the y-axis, is the same idea. Replace the x with opposite x in the equation. If the equation is unchanged, and again, you may need to do a bit of math to see, it's symmetric about the y-axis. And finally, symmetry about the origin. I'm guessing you're ahead of me on this one. In this case, we're going to replace the x with the opposite of x, and the y with the opposite of y in the equation. And if the equation is unchanged, again, you may have to do a bit of math, it's symmetric about the origin. So let's speak to unchanged may require a bit of math to see. Okay, you may have to do a little bit of math to make sure it's unchanged. So we'll see some examples of that in just a minute. So those are our tests algebraically. We're going to do this both algebraically, and we're also going to look at our calculator, because obviously the calculator test is pretty simple. Okay, I'm going to go on another sheet of paper because I want a bit more room. Okay, so here we are at example 1. Let's test y equals 1 over x for symmetry. Okay, so symmetry about the x-axis. All right, we know. Replace y with the opposite. Whoops, I shorthanded my with, which I sometimes do. Replace y with the opposite of y. Okay, so here is my equation. Y equals 1 over, oh boy, a couple mistakes here already. My equation is y equals 1 over x. Let's replace y with the opposite of y. Okay, replace y with the opposite of y. And is this the same? Well, you probably can see that it's not. You could do, let's see, I'm going to do times -1 on both sides. And I'm going to get y is equal to the opposite of 1 over x. And this is clearly not the same. If you couldn't see it here, you can certainly see it here. Now, the bit of math was I did the same thing to both sides. That does not change the equation. And you can see not the same. Not the same. Whoops, yeah, I thought I misspelled it. Not the same. So, not symmetrical about the x-axis. Okay? Let's see if it's symmetrical about the y-axis. Okay, so we're going to replace, remember, for every y, you could have two x's, the x and opposite of x, because symmetrical about the y-axis means one y has two possibilities. So we're going to replace x, I keep doing that, sorry about that, replace x with the opposite of x. Okay, so here's my original equation, y equals 1 over x. Let's replace x with the opposite of x. And if you want, I'll use parentheses. It doesn't matter really. Okay, replace x with the opposite of x. And is this the same thing? Okay, and I can remove the parentheses here. I can pull the negative out front if you want. Again, clearly, this is not the same thing. Y equals 1 over x is not the same thing as y equals the opposite of 1 over x. So again, not the same. Okay, so not symmetrical about the y-axis. Okay, I'm going to slide it up and let's take a look at the origin. Okay, let's see here. Let's test it for the origin. Okay, the origin, we get to do both. We replace x with the opposite of x and y with the opposite of y. So here's my original, y equals 1 over x. Let's replace y with the opposite of y. And let's replace x with the opposite of x. Okay, so here is after replacement. You'll notice that's easier to write than to write replace x with and y with. Okay, and here we are. We're thinking, that's not the same. Those are different. But wait a minute. If I were to do a bit of math and I were to multiply the left and the right side by -1, again, which I can do, that will not change the fact that it is an equation. It won't change the equation. I come up with y is equal to 1 over x. Okay, again, just a bit of math. Hey, these are the same. Okay, so it's symmetrical about the origin. Okay, all right. So there you have it. Let's take a look at our graphing calculator and see if we can see it. So I'm going to come into here. I think that's pretty straight for you. And I'm going to go into my y equals. I'm going to put 1 divided by x. So there I am. Y equals 1 over x. And I'm going to go into my zoom and make sure I'm in my standard window. Here's my standard window number 6. And I'm going to graph it. And there you have it. Okay. So you can see, okay, is it symmetrical about the x-axis? Well, here's the x-axis. If this folds down and this folds up, they're different. Okay, you can have a different graph. Okay, now let's fold it on the y-axis. Well, if this goes to here and this goes to here, again, it's not going to match up. So they're different. So it is not symmetrical about the x-axis or the y-axis. Now let's rotate it. So put a pin in the origin. If I rotate it 180 degrees, this will become this, and this will become this, with a rotation of only 180 degrees. It has to be, if it doesn't matter about 360, it has to be less than 360 degrees. This requires a 180 degree rotation to match up. Therefore, it is symmetric about the origin. Okay, let's do one more example. Okay, example 2 here. And let's test this one. Test this one for symmetry. Okay, so let's first do the x-axis. Well, I'll tell you what, let's do this first. Let's see what the calculator says, what the graph says first. And then we'll come and do the math. So y equals, let's clear this. I'm going to use my, my fraction bar. So x squared, what can we expect? X squared minus 4 numerator, x squared plus 1 denominator. Let's press graph. So here is that. Okay. Well, I think it's pretty clear that if we fold on the x-axis, we're not going to match up. So it should not be symmetric with respect to the x-axis. If we fold on the vertical y-axis, it does match up. This will match with that, this will match with that, etc. So it looks like it is symmetrical with respect to the y-axis. And clearly, if I put a pin in the origin and I rotate it, it's going to require a full 360-degree rotation to get back. The only way this point's going to come back to here is going all the way around a full circle. So I would suggest it is not symmetrical with respect to the origin. Let's see mathematically, and we'll do this a little more quickly. Okay, so the x-axis, replace y with the opposite of y. Okay, so y is equal to x squared minus 4 over x squared plus 1. Let's replace it. Is this the same thing? Whoops. I replace y with negative y. Do I get the same thing? Well, if you can't see no from here, let's multiply both sides by negative 1. And I come up with y is equal to, well, this is going to be negative x squared plus 4, right? That's negative 1 over x squared plus 1. Multiply by negative 1 over 1, and certainly that's not the same thing. So not symmetrical about x-axis. Okay, let's try the y-axis. We know from our graphing calculator that this one should work. Replace x with the opposite of x. Okay, so here's my original. Y equals x squared minus 4. Oops, a little sloppy there, sorry about that. Over x squared plus 1. This is the original. Now let's replace. Everywhere you see x, let's put in the opposite of x. The opposite of x squared minus 4 over the opposite of x squared plus 1. Well, it looks different. However, the opposite of x squared equals x squared. So, this is the same thing. Opposite of x squared, a bit of math, is the same as x squared minus 4 over x squared plus 1. So, same. So, symmetrical about the y-axis. And again, we knew that from our graph. Let's check our origin. Okay, we're going to replace x with the opposite of x and y with the opposite of y. So I'll tell you, I'm just going to go ahead and do that. So we know my original. Well, I'll put my original down. Y is equal to x squared minus 4 over x squared plus 1. Let's replace. The opposite of y is equal to the opposite of x squared. Whoops, another mistake there. Minus 4 over the opposite of x squared plus 1. And we know from this one that the opposite of x squared is equal to x squared. So the opposite of y equals x squared minus 4 over x squared plus 1. And we know from this one right here that that's simply not true. We saw how that one changed to this. So we know that this is not the same. Not the same equation. So not symmetrical about the origin. Okay. So again, quick recap. Symmetry about the x-axis. Replace the y with the opposite of y in the equation and see if you can get the same equation back. If you can, it is symmetric about the x-axis. Symmetry about the y-axis, replace the x with the opposite of x in the equation, and then see if you can get back to the original equation. Okay, and symmetrical about the origin, replace both the x with the opposite of x and the y with the opposite of y in the equation, and then see if you can get back to the original equation. If you can, it is symmetric about the origin.